Hello everyone, welcome to our final project Spam or Ham. This is Yunshu Zhang and my partner Ying Zhang. Spam detection is a standard text-based two-class classification problem. Spam detection automatically identifies unwanted messages and remove them, which greatly improving users' experience. We found this topic is super close and related to our course since in Chapter 6, Spam or Ham topic has been introduced. Therefore, our project will focus on first, how we implement book example. Second, use full dataset we get from internet and develop more advanced feature extractions and machine learning models. So let's start with the book example. In this example, we perform two-class classification on a spam detection dataset that book provided. After importing and normalizing dataset, we use gradient descent to minimize the softmax cost. We calculate the accuracy based on the smallest numbers of misclassification. Properly minimizing the softmax cost, we can achieve about 93% accurate over the entire dataset. Then we want to perform some advanced feature extraction based on raw dataset. SMS spam collection dataset is downloaded from UCI machine learning database. For this set, we have about 5,500 data points in total, labeled as ham and spam. Messages are in English. Beside the graph we made to analyze the dataset, we also change ham and spam as 0 and 1. Last thing we want to apply is to split dataset into train and test. We use two methods to extract features from raw English messages. First feature method we use is bag of words. Using bag of words package to build up the frequency of word matrix. This method converts a collection of text document to matrix of token. For example, if we have two sentences, the cat sat on my face, the dog sat on my back, then the matrix turns out to be like this. Mark the words to be 1 if the sentence contains this word, otherwise mark it to 0. Second feature we try to implement is TF-IDF. Using TF-IDF package with weight to extract word features. Still using the example shows above. Since TF is the number of occurrence of the words, the TF matrix is different than the bags of word matrix above. This time by applying the equation, we will also get our IDF matrix too. Then dot product to matrix, we will get our TF-IDF feature extraction matrix.
In this section, I'm going to talk about the second part of our project, where we use different classifiers, including naive Bayes classifier and decision tree to actually train the model using our training data, and also testing it with some sample testing data. So here we import the multinomial naive Bayes from the sklearn library, and we instantiate an object out of this class. We then apply our fit method into our classifier using the transform input and the label value as output. And then we test to see if the classifier actually makes sense or not by writing two messages in a way that one of them is spam and another is ham. And then we take that data and actually transform it again using count vectorize, and then we pass along translate data into the predict method of the trained model, which it gave us 1 and 0. And this actually makes sense because remember our first message is spam and second is ham. And then next we're gonna divide our data into training and testing. So we import the train test split from the sklearn library, and in the method we pass our x, y, and test size. X is again our transform data, and y is the label value. After we have this trained model, we can evaluate using the configuration matrix and the classification report. As you can see from this plot, we only classify 7 samples, which is not bad. We also print out all the accuracy score for both the naive Bayes and the decision tree. And as you can see from this plot, the naive Bayes actually works pretty well for spam detection. So in conclusion, using feature extraction such as bag of word or TF-IDF and advanced machine learning model such as naive Bayes or decision tree will achieve higher accuracy score compared to softmax. So that's all for our project. Thank you for listening.